Going to work through today's lesson is solving logarithmic equations. There's several different types of logarithmic equations. I have one version up here where you actually have a log on both sides, which is the easier version of what's there. And then it gets a little bit more challenging. So ideally, if we're able to rewrite sides of problems and condense logs, we want to rewrite and condense. So that's what this first statement is. That mainly comes into like problem number 4. Problem number 4 there, we have to condense first before we can do anything. So that's the first thing, so on number 4, just a little right note. So like on problems 1, 2, and 3, we don't have to do any condensing. We can go ahead and go to this one-to-one property is what we're allowed to do. And then we go through the process and we solve for x. Here's again this thing here, extraneous solutions. We had that word happen before. Anybody remember when we had the terminology extraneous solution come about? Yeah.
Wasn't it like solving radicals?
Yes. It was when we were solving radicals. It was when we did the proper solving. We got an answer or two. When we went back to the check step, one of them didn't work because it didn't balance the problem. Okay? Same thing is in this world of logarithms. And there's a reason why. We are not allowed to take the log of 0 or less. Can't take the log of a negative number or 0. It has to be a positive number. Now, it can be a small decimal. It just can't be 0 exactly or a negative number. And so that's why when we go through our solving process for x and we do this stuff and we find it, if the x value makes us take the log of 0 or the log of a negative number, then we got to stop and say that x value is an extraneous solution. Okay, we'll see if it arises. But again, we saw that terminology before. So on number 1, we don't have to condense. So this is the one-to-one property. It says if you have on one side of the problem log base b of something, and it is equal to the log of the same base of something else, then we can just set the two things equal to each other. We can set the m and the n equal to each other. Now, if the bases are not the same, then we cannot use this property. So with that in mind, on number 1 here, we notice that we have log base 5 on both sides. So since it's the log of the same base, then really I can rewrite this as 5x plus 9 equals 6x, and I can solve for what x is. And then now I just say subtract the 5x, subtract the 5x. I get 9 is equal to x. And then again, I have to check because, I have to make sure it balances. So we go through and say in the check step, is log base 5 of 5 times 9 plus 9, is that equal to log base 5 of 6 times 9? Yeah, it's log base 5 of, it's 45 plus 9, which is 54. So log base 5 of 54 is what is on the left side. And then we know that 6 times 9 is 54 on the right side. So since those are identical, both sides are the same, then, hey, we know that that is the solution, that x has to be equal to 9. Again, we don't have to make them decimals. We just have to, do some quick simplifying. Again, number 2, we check to see, do I have the same log with base? I do, so that means I can use this one-to-one property, and I can just set the two things equal to each other. 1 minus 4n equals 2n plus 43. And then now I use my 7th grade and 8th grade math skills to solve for n as we do it. I'm going to subtract the 43, and I'm going to add the 4n at the same time. So subtract 43, man, it got quiet. Add the 4n. And I have negative 42 equals 6n, divide by 6. N is equal to negative 7. Now, we don't freak out because n's a negative number right now. We have to plug it in to see, am I eventually taking the log of a negative number when it's all said and done through simplifying? So now we would go through in our check step, is log base 2 of 1 minus 4 times negative 7, equals log base 2 of 2 times negative 7 plus 43. Negative 4 times negative 7 is positive 28 plus 1 is 29. So that's log base 2 of 29. On the other side, 2 times negative 7 is a negative 14. Negative 14 plus 43 is 29. So that actually is okay. So, hey, those left and right sides equal, so I know that negative 7 is my solution. And then number 3, same thing. I notice it's log base 9 of both sides, so I can go ahead and set the stuff equals. There was no condensing that needed to be done. So 6 minus 3w equals negative 2w. And then I'm going to add the 3 across. You okay there? Okay. If you need to grab a drink of water at any stage, you don't have to ask me if you feel free to, okay? All right, so I got w is equal to 6 as I did that. Yes, buddy. Yeah, go ahead. I got w is equal to 6. So now I go into my check stage and I said, okay, log base 9 of 6 minus 3 times 6. Are you equal to log base 9 of negative 2 times 6? And then this is where I would kind of freeze myself. I notice on the left side it says log base 9 of negative 12. And on the right side it says log base 9 of negative 12. And if we're not careful, we would say, hey, it's the same stuff, so it's got to be the solution. But then we got to remember the little formality part about logarithms. We can't take the log of a negative number. So even though the left and right side did balance, we can't take the log of the negative number. So this one we would say there's no solution. Here we would say can't take log of negative number, so no solution. The w equal to 6, that's technically an extraneous solution. This is my extraneous solution. It was a solution, again, that we solved for. However, when we test it, when we check to see if it balances our equation, it did balance, but then it made it faulty because we can't take the log of a negative number. So that's where we got to make sure we remember those extra characteristics about what are we allowed to take the log of. We just can't take logs of negative numbers or 0. So they nicely gave us one of those pretty quickly, which was good. Sometimes they wait forever on these worksheets to do that. Number 4. Here I notice I have the word log twice on the left, once on the right, which means I need to condense. So I'm going to condense the left side. I notice that there's a plus sign between the two words of logs. Going back to what we learned in the previous lesson, if I'm adding two logs together, then that means I can take the log of the two things being multiplied together. So I'm using that addition rule. When I am adding two logarithms together, I can multiply the two things together that are after the words logs on the one side. I can condense that one side. And so now I'm gonna distribute the 4. So let's go ahead and distribute the 4. So we'll distribute the 4 inside to the y and the 5. So log of 4y plus 20, that's equal to the log of 72. Now I have the word log once on each side. Now I can go ahead and use the one-to-one property. So now I can use the one-to-one property and say that 4y plus 20 equals 72. And I can now solve for what y is. So subtract the 20. I get 4y is equal to 52, divide by 4, and I get y is equal to 13. And then I need to check it. And this one we can use our calculator. Do you have a calculator handy? We can use the calculator to help us check on this one. Since it's base 10, remember there's no number by the G. So if I go to check it and I say, okay, the log of 13 plus 5 plus the log of 4, is that equal to the log of 72? All right, so log of 18 plus log of 4, are you equal to that? Now, I heard the yes, and I appreciate that. I'm going to type it in here real quickly on the calculator because, again, we don't have to simplify it any further than that. I can actually go through and say log of 18, close the parenthesis. Ooh, that's a tangent button. Log of 18, close the parenthesis, plus log of 4, and I get an answer. So 1.857332496. Then I say, okay, what is the log of 72? Hey, those are the same decimals. Thank you, Willie. And then that's how you can do it. You know, do the little math, do the 13 plus 5, but then type the rest of it in and let's say that, hey, well, does that work out? If you wanted to use the change of base, you could do that too. If we didn't have base 10, you could use that and say the log base, whatever this, plus the log base, this, you know, does it equal that other side? So you don't have to use a lot of properties to do the double check stage. Okay, so we know this is a solution. And then now we start getting some variations of it where they start getting a little bit more challenging in there. So right now, I can't get rid of the word log base 7 because there's a 3 in front of the log base 7 on the left side. So what do I need to do with that? What do we
Behind the 4.
We do where?
You put it behind the 4.
And in what aspect do you mean by behind?
Like, you raise it.
You raise it, thank you. Behind meaning raise it to a power. So in that case, the 3 as a coefficient becomes the exponent. So it's log base 7 of 4 cubed equals log base 7 of 4a minus 8. I have the same bases. So I'm going to go ahead and cube out 4, so that's 64. And that's equal to 4a minus 8. And then I can go about solving for what a is. 72 equals 4a, divide by 4, and I believe that's 18. And then I get to check it. Now this one I only get to check it on the one side. Okay? Now we do know, based on what we did on the here, when we had three logs, again, you can type that in. I mean, if you don't want to, I'm running out of room, so let's just type it in. 3 log. We got to do change of base. My bad. 3 alpha window. Option 5. And then I'm going to put in my base 7 of 4. So there's that one. I'm going to get that decimal. And on the other side, again, it's alpha window. Option number 5 gives you log base. And then I'm going to put in base 7, get into parentheses, and I'm going to tell it to do 4 times 18, subtract 8. I'm being super lazy after having these 4 days off. I'm going to let it do all the work for me. Hit enter. Are those the same decimals? Yeah. Okay. So just trying to save myself time to having to write it all down there since I'm writing really big here. We can type it in and let it do it for us and check to see if we get the same decimals on both sides. Which again, we need to do the check step. If you didn't get the same decimals, I'd go back to make sure you typed things in there correctly because it's easy to have happy fingers and miskey something. Okay. Let me give you a minute to do that one. Let me give you about a minute head start to do that one. Because the rest of them are just using some of those properties is what they're doing. Yo. Yeah. So I'm thinking n is equal to 2. Is what I'm thinking real quickly. Let's double check to make sure I did that right. So on the left side, when we're subtracting, what do I get to do to the two numbers as I condense? If I'm subtracting bases, then I get to do what with the numbers? Divide them. So 68 over 4. So that'd be the log base 4 of 17. The right side is just hanging out, just waiting. Said finally you got your act together. So now I can say that the logs cancel by the one-to-one property. I get 17 equals 3n plus 11. And then now as I subtract and solve for n, I get 6 equals 3n. And n is equal to 2. And then I go through there, and then again, we can use the calculator, use the change of base formula to get ourselves practice, making sure we remember stuff. Again, because we've had those days off, so it's not a bad idea. So alpha window, option 5, log base 4 of 68. And then minus... Mr. Stevens, you doofus. There we go. Alpha window, option 5, log base 4 of 4. I got to get rid of that extra parenthesis. Didn't like that. Man, mine's going to be better. Anyway, it does balance. I don't want to retype all that stuff in. So, it does balance. It checks. All right. So that's the first type. Here is type 2. Ooh, look at this one. That one's got an m squared in there. Let's put that in our notes. Let's do number 9 before we go on to the next one. Let's put number 9 in there because we need to have an example of that. So first off, do I need to condense? Nope, don't need to condense. Those two things cancel. So I have m squared equals 18 minus 7m. This brings us back to the third week of the semester. I got to bring everything over to the other side. And I got to solve for my quadratic function. I got to get everything over here. And then I got to factor. Told you that word just keeps coming up over and over and over again. So I get my m is equal to negative 9, m is equal to negative 2. And then I have to go in and check, do they work? Do they both balance? And so let's see, if I go up to my problem here, log base 4 of negative 9 squared would be the log base 4 of 81. And then on the other side, it would be log base 4 of 18 minus 7 times negative 9. 7 times, or negative 7 times negative 9 is a positive 63. 63 plus 18 is 81, so that worked. So that is an answer. So I know that works. Now I got to put the 2 in there. So when I put the 2 in there, it'd be log base 4 of 2 squared, which would be log base 4 of 4. On the other side, that would be log base 4 of 18 minus 7 times 2, which would be log base 4 of 18 minus 14, which is 4. So hey, yeah, that works too. So that's 2 solutions for that one. And just like we did in the earlier unit with radical functions and radical equations, we got to test them both. If both work out to be extraneous, then we would say no solution. So. All right, now what happens? What happens when you don't have log on both sides? Well, first thing we need to do is make sure we condense and isolate logarithms. Do those in the first couple steps. Then we're going to rewrite it in exponent form or exponential form. That was our first lesson last week of rewriting from exponent to logarithm and logarithmic to exponent. Then that's what we're going to do, and then we're going to solve. So, for example, on number 11, there's no rewrite, no condensing. The logarithm is already isolated, so I'm going to rewrite it in exponent form by saying 2 to the 6th power equals x minus 4. 2 to the 6th power, the base to the answer equals the thing that was after the word log. And then I'm going to start solving. So that's 64 equals x minus 4. And then that means that x is equal to 68. And then again, I should always check. Is log base 2 of 68 minus 4, does that equal 6? All right, let's use the calculator. All right, so alpha window, option 5, log base 4 of 68 minus 4, as I'm about tapped out for the day. Oh, yeah, I did. You're right. Thank you, sir. 2. All right, so if I do second enter, go all the way back and change that to a 2. Hey, there we go. That's 6. Good catch. Number 12. Again, remember, you can always work ahead of me if you want. Number 12, I need to move the 7 first. So I need to add the 7 across. Log base 3 of the quantity 4x plus 8 equals 4. Now again, notice how I am not distributing the log into the word or into the parentheses. All right, we do not distribute that log into the parentheses. All right, we do not do that. The 4x plus 8 is a contained parenthesis, so we would not split it up into 2 logs either. We wouldn't say log base 3 of 4x plus log base 3 of 8. We don't do that. We remember we have to be multiplying in order to split it up. So now I can rewrite it as 3 to the 4th equals 4x plus 8. 3 to the 4th power is 81. And then I'm going to subtract the 8. And right now, Mr. Stevens thinking to himself, did he make a goofy mistake? Because if I know 4 doesn't go into 73 evenly. Did I make a goofy mistake? Do what? 3 to the 4th power is 64? Okay. No, 4 to the 3rd is. Yeah. But again, here we're trading the base. The 3 has been that. The 4 is trade places. All right. So yucky decimal. So I'm going to leave it as a fraction since it doesn't go in there nicely. And then I'm going to let the calculator check it for me. So alpha window, option 5, log base 3. In the parenthesis, I have 4 times alpha x gives me a fraction. And that's where I'm going to put my 73 over 4. And then after the fraction, I'm going to put a plus 8. All right, so that looks like that's the whole left side, it looks like. Then I just have to subtract the 7 in the back. So that's the whole left side. Fingers crossed that we get a negative 3. Woohoo! Sweet. We got a negative 3. Okay? Now, did the log work out to be a negative number? No. This minus the 7 is what brought me down to be a negative number. Okay? So, typically when you take when you take the log of proper fractions, the log of numbers between 0 and 1, you should get a negative answer. I know we showed the exponential decay, and growth graph. Did we show the logarithmic graph last week at all? I don't think we did. Okay. Let me show you what the logarithmic graph has here. So let's show you this. So the logarithm graph, and again, you can always graph it on your calculator, but if you go off to the side here and we do y is equal to log x, that graph hugs the y-axis, comes up in quadrant 4, crosses, and grows like that. So basically and it crosses here at 1, 0. If you take the log of 1 in your calculator, you'll get 0. If you take the log of 0.5 in your calculator, you're going to get a negative answer. Okay? So that's the log graph. The ln graph, it looks identical. So y equals ln of x. That looks almost identical to that. The only difference is it doesn't cross at 1, 0. That graph actually crosses at E. So it hugs and it crosses at E. Because on your calculator, if you hit the ln button and then you go second ln to the first power, it's going to give you a 1 for an answer. So, actually, no. Let's trade that back. It's still 0. It's still 1, 0. I don't know where my brain was on that one. So, scooch that back over. Rewind. This is where I need to learn how to do an edit on YouTube. Go back and redub my voice over that part. Cut and splice it. So, still 1, 0. It just happens to be at E. It's at 1. There we go. Sometimes you have a good thought and it backfires on you, so you got to go back and rephrase it. So the ln of E is 1. Here we go. All right. Dun, 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 dun. Why don't you try number 16 for me? Give you a head start on 16. Think about how you need to condense the left side. Since I am adding the two word logs together on the left side, that means I get to multiply the two things together that are after it as I go to condense. So then this becomes the log of x squared minus 3x equal to 1. Now we rewrite this in exponent form. Remember, I have technically a 10 down there on the tail of the G. So 10 to the first power equals x squared minus 3x. Then we move the 10 across. We get 0 is equal to x squared minus 3x minus 10. Then we think about factoring. And then I get my two answers are x is equal to 5 and x is equal to negative 2. Well, real quickly, just me looking at it, the negative 2, x equals negative 2, if I put that into the equation, I got the log of negative 2. So that's extraneous. That one's the extraneous solution. Now, if I put 5 in there, is the log of 5 minus 3 plus the log of 5, is it equal 1? So now let's type that in there. is the log of 5 minus 3 plus the log of 5. What are you? Hey, you're 1. Sweet. So that tells me that's my solution. Questions so far? All right. So there's the solving logarithms. Now we get to go into solving exponential functions where we have the x in the exponent location. So just to remind you, we did some of this with the exponential growth and decay. Can you rewrite on problem number 1? Can you rewrite it to where they have the same base? So can you write, we know it's 5 to the n plus 10 power. Can you rewrite the right side so that it has, it's 5 to a power? Yeah, so let's do it. So that means I can rewrite this as 5 to the n plus 10 equals 5 squared. When I have the same base, I can set the exponents equal to each other, and I can solve. So n has to equal a negative 8. And then again, as always, we should always check, is 5 to the negative 8 plus 10? Well, that's 5 squared. That's 25. So yes, that balanced. Yo. On number 2, can we rewrite 27 as 9 to a power? It's not pretty, so I would say no. So here, now we need to think about rewriting both numbers. 9 and 27 are actually what number to a power? Okay, 3. So with that in mind, we would rewrite this, the left side, as 3 squared to the a plus 2. That's how we would write our first step. 3 squared raised to the a plus 2 power. On the other side, it is 3 cubed, all that raised to the 4a minus 2. That's how we would rewrite our first step. The power to power law with exponents says if I have a power to power, I can multiply the two exponents together. So that means I get to take the power of 2 here and distribute it to the a plus 2. So that now becomes 3 to the 2a plus 4 is what that power becomes. 3 to the 2a plus 4. On the other side, I would distribute the 3 to both parts of that exponent. And on the right side, we get 3 to the 12a minus 6. Now we have the same basis. So now I can say 2a plus 4 equals 12a minus 6. And then now we solve for a. I'm going to add the 6 and subtract the 2a. I get 10 is equal to 10a, so a has got to be 1. And then now I have to check it. And this is where using the calculator helps us out. Is 9 to the 1 plus 2, which is 9 to the third, is that equal to 27 to the 4 times 1 minus 2? So that would be 27 squared. I know that one's 729, the first one. What's 27 times 720, or 27? 729. So, hey, it does work. All right. So I'll give you a chance to make sure you catch up on your writing on that one. Now, sometimes we're not that lucky and we can't rewrite both bases with a common base to a power. Okay, so then we use logarithms to help us figure it out, is what we go through here. So, as always, we isolate the exponential expression. We take the log of both sides, You may need to expand the log by using the power rule. And then we solve and check. And they tell us here round-ended answers may not produce exact same answers, but close. So if you happen to take it to a decimal, and a decimal is going to be irrational, if you round it, when you go to check that decimal, it's not going to balance it. It's not going to be perfect. That's what that little disclaimer is there. Because very rarely, when you're having to do this next process and you're solving for the variable, you're not going to get a nice, pretty number. It's not going to be a terminating decimal or like a nice, pretty, proper, easy fraction. Okay, so that's what their little thing's saying. If you round it and you go to test it, it may not balance, but it should give you an idea that you're pretty close, especially if you use a lot of decimals. So on this one, I don't have to do any isolating. So this one I can rewrite it, and this is I think the easiest. Log base 2 of 2 to the x equals log base 2 of 61. Whatever your base is, whatever that number is being raised to the x power or the exponential power, whatever it is, do the log of that base to make your life easier. You can do log base 10. The challenge is it's going to take a lot more steps. It's going to take more steps to get through it. So I would take the log of both of the base that you're dealing with on both sides. So now, when we see this, the log base 2 of 2 to the x is just x. And then now on the right side, I get to find the answer with the calculator using that change of base formula. So on the right side, we can go through, say, alpha window, option 5, log base 2 of 61, and I get 5.9307. Now, if I say 2 raised to the 5.9307, it comes out to be 60.998. Is that close enough to 61? Yes, okay? And so that's that little statement in the directions where it's saying, hey, if you round the answer, like the log base 2 of 61, I rounded it at the 4th decimal place. I'm going to get close. I'm not going to be exactly 61. If I used more decimals, I probably would be, okay? But again, this should be enough to let us know that, hey, yeah, we did it okay. We got close to that. Number 4, I can't rewrite 92 as 8 to a power. It's already isolated as 8 to a power, so now I just do the log base 8 of 8 to the m minus 7. That's equal to the log base 8 of 92. On the left-hand side, the log base 8 of 8 cancel, and I'm left with m minus 7 equals log base 8 of 92. I'm going to add the 7 across. Now, here's where we got to be careful. It is 7 plus the log base 8 of 92. You're not allowed to add the 92 and the 7 together. Okay? So that 7 gets moved over, and I like putting before the word log. That way I don't make a goofy mistake and put it after it. And I see a 92 plus 7 and do 99. Okay? We are not allowed to add a normal number to the log of a number and simplify it. We have to get it as a true decimal. Then we get to add the 7 to it, is what we get to do. All right? So now if I wanted to find, this is the exact answer. So if they're asking for the exact answer, that's the exact. So 7 plus alpha window, option 5, log base 8 of 92. And we get 9.1745. And again, if I want to check 8 raised to the 9.1745 minus 7 power, that's pretty close to 92. Okay, so in my mind, I'm like, hey, yeah, I did it right. I got an answer pretty close. If I was rounding it to the nearest second decimal, I got 92 when it rounds up. So I'm okay. I feel confident with that answer. Why don't you try number 5? And then compare with your neighbor next to you. When they get done and you get done, did you get the same answer for him? You have to have 92 log base 8 of 92 and then plus 7. So it has to go 7. Yes, we are. How you start? All right, so we need to isolate the 7 to the n power. So the first thing we need to do is get rid of that 4. So I would, this is the first one we actually have to move something over to the other side. So I would actually, yeah, I would divide 148 by 4. That's what I would do first. So 37 is equal to 7 to the n power. Now I can do log base 7 on both sides. Yeah, whatever you do on one side, you're going to be done on the same other side. Now, that n is an exponent.
Yeah, that's what I heard.
Put down a 7. And then on the top of the 7's exponent.
Oh, yeah, that's right.
Now, those two things cancel. And the n comes down. Okay? No log. They cancel. When this cancels that, it means the log goes away. You're just left with
So that it gets a more accurate number.
Yeah, no, 37. That's it. Okay. All right, I'm going to catch up slowly to you. All right, first thing we're going to do, we got to isolate it. We got to isolate the 7n. So I get 7 to the n equals 37. 148 divided by 4 is 37. Now I do the log base 7 of 7 to the n power. That's equal to log base 7 of 37. Properties of equality. Whatever you do to one side, you got to do exactly to the other side. So we divided both sides by 4. Since I want to get rid of the base 7, I need to do, the quickest thing to do is to do log base 7 of the 7 to the n. That way, the log base 7, that stuff cancels, and I'm just left with n. And then now on the right side, I get to type that into the calculator. Alpha window, option 5, base 7 of 37. 1.8556. As I just scroll, as I zoom, oh, here's a real life one. Hey, let's do a real life one. It's always the question, when will I ever use this in my life? So, for my marine biologists sitting here, when you're dealing with the scalloped hammerhead sharks, because you decide you're doing marine biology. You know, there are scholarships if you go like to a school. I know Kentucky does this, and some other states do this as well. There's a southern states scholarship. If you go to a school that like marine biology, and you go to Kentucky and they have it as a major, you can get it as you can be an in-state student at that school and stuff. So as opposed to like if you went to Alabama, you wouldn't be an in-state student. But if a state in that pact, offers a program that to do, you can get in-state tuition for it. So just plan. We looked at that with my daughters when they were looking at doing things of toying around of saying, hey, let's do this major here, and because then you can get in-state tuition, which chops off 15, 20,000 sometimes a year and stuff. So all right, Modeling in real life. The length in centimeters of scallop hammer-shelled sharks can be modeled by the function L. The length is equal to 266 minus 219 e to the negative 0.5 t power, where t is the age in years. How old is the shark? That's 175 centimeters long. Round your answer to the nearest tenth. All right, fantastic. So in that case, the L is equal to 175. We are trying to solve for t, which is the age. So I'm solving for t, which is the exponent. So let's put in the 175 for the L. 175 equals 266 minus 219 e to the negative 0.05 t. There's a decimal point between the, or a 0 between the point and the 5. So it's a decimal point 0.05. All right, so now we just start doing inverse operations, start isolating for that t. So first thing I'm going to do is subtract the 266. And so I'm going to get a calculator up here because that's just too big of math. I mean, I guess I can say it's, you know, what, 80 or 91-ish or something? I don't know. So 175 minus 266, negative 91. Now, don't drop the signs. It makes a big deal in these things if we drop a sign. So we got to be very careful. I need to now, again, is the E, is it isolated where the exponent of t is? No, so I need to divide off the negative 219. The negative 219 is attached through multiplication. I got to divide it off. So now on the left side, I have 91 divided by 219. I went ahead and said negative divided by negative is a positive. I don't think that's a pretty decimal. Sorry, wrong numbers. 91 divided by 219. So I'm going to leave it as a fraction as I go through my steps here. So that's e to the negative 0.05 t. All right, so now, what is the inverse of e? Well, if we look at our calculator, as I try to zoom in. Oh, come on, you little pooper. All right, anyway, it's not cooperating with me. Technically, E and ln, they're inverses. E and ln are inverses. So what that means is I want to take the ln, the natural log of both sides. And the reason why I do that is that way, since E and ln are inverses of each other, that means that the ln and the E cancel. And now I'm left with the ln of 91 over 219 equals negative 0.05 times t. Yes?
What's ln?
Natural log. That's log base E. Good question. You were gone last week. ln is equal to log base E. There is a special button that says ln on your calculator. That is log base E. Whereas if we saw just the word log, we know it's base what? 10. Okay? Second ln gives you the E. The E to the x. Okay? So now, with that in mind, again, we had some rain days. Okay? So now I need to divide both sides by a negative 0.05. And so t is equal to whatever this fraction is. ln of 91 over 219 divided by a negative 0.05. I'm making sure I didn't copy anything down wrong. No, it looks pretty good here. All right. Now, I'm double checking because right now the way it's set up, what does it look like the top? Before doing, nobody who put it in the calculator, don't say a word. All right, you put it in the calculator, you can't answer this question. Right now, as I look at it, the top looks like what type of a number?
Negative.
Right now, the top.
A bad.
Positive, right? The bottom is a negative, right? No, don't worry about flipping. But doesn't that what it looks like? It looks like we got a positive divided by a negative, which we would think is what?
Negative.
Negative. Okay?
How do you know?
Okay. So we got to be careful. This is where dropping signs makes an issue. When we take the log or natural log of a fraction, this answer is going to be negative. So then we'll have a negative divided by negative as a positive. Otherwise, if we don't, can you go back negative years on the life of the shark? No. So that's where the signs make a difference. All right. So I'm going to go type this in one fell swoop because I feel very confident with my calculator abilities. So alpha x gives me clear that screen. Alpha x, I'm going to go ln, and I'm going to do alpha x again to give me a fraction, 91 over 219. I would always close a fraction, or the ln, I would close it. So I have the ln of 91 over 219, go to the bottom of the fraction, negative 0.05. And then I'm going to hit enter. And this tells me that t is equal to 17.5642. So the shark is 17.5 years old. So a shark that is 175 centimeters long. Again, we're Americans. We have no clue what that means. So take 175 and divide it by 2.5. What's 175 divided by 2.5? What is it? What is it? 7? 70. So that's 70 inches. Okay? Because that puts it more in context for you and I. Okay? So there's 2.5, roughly 2.5 centimeters to an inch. Okay? So with that in mind, you're looking at roughly a 70-inch shark, which you said what? About 5 foot 8 inches. Okay, so who are my 5'8" people in here? That's how tall the shark is. Okay, I'm 5'10", and I'm not a half anymore because I'm over 50. So I sure. What do you think? Well, it depends. I didn't see what they said. What did they say round one?
Well, we rounded it to 17.5.
Yeah. You're being busy. Now,
It would be a 6.
yeah, it would be a 6, but you know. Oh, nearest 10th. There we go. So yeah, it would be 6. In that case, there you go. Yes, go. All right.
No.
But I
I just imagined it as we were like 17 and a half years old. I didn't think of it as like around 17. Because why would you say you're 17.6 years old?
I literally say that all the time. I'm literally 16.6 years old.
6. That
No.
I just learned it. No. So why is it called?
That would be over half.
Yeah.
That means I didn't do it.
that was just skip the grade.
I felt for my gal when they said about the shark.
Because it started in
I felt Oh, we're back to this.
All right, one more problem. One more problem. There's a reason why. There's a reason why. All right. The other word problem got me because we got to do logarithms, the ln. We had to use the ln to cancel things out. I had to create another one where we just use the word log in order to get the cancel out. Okay. So here is going back to our exponential growth stuff. Here's a situation where I'm investing $5,000 at 5% interest compounded quarterly. How many years will it take for it to be worth $20,000? Okay, so I'm going to walk you through the setup. Again, it's been a week since we did the compound stuff. Okay, so I want to set up the original formula, walk you through on how you solve for t. Because when we set this up, the only thing we're missing is t. So as we set up our equation, the amount after a certain amount of time, so a of t equals $5,000 times 1 plus my interest rate divided by the compounding raised to the compounding times t. So again, this formula, I know you don't have it memorized. Okay, there's the formula I just used. And I want to figure out, when does that formula equal 20,000? When does that formula equal 20,000? How many years is it going to take that to happen? And so we're going to use logarithms to help us solve for t, is what we're going to do. Now let's simplify inside the parentheses first. What's 0.05 divided by 4? Isn't it 0.0125? Okay. So I get 20,000. Again, you can simplify a little bit different, but I'm just taking our out slow. Just like the tortoise. All right, so I always like simplifying, because the most common mistakes that are made is on the inside of those parentheses with that rate divided by the compounding, is when I see kids make mistakes. So now I'm going to divide both sides by 5,000. I need to isolate 20,000 divided by 5,000 is 4. Now, you got options. We can do it just like we've done before with that log base. If you want to use log 10, you can use log 10. You don't have to. We can do the same thing. Log base 1.0125 of 4 equals the log of 1.0125 of 1.0125 to the 4-letter t. It looks crazy. All right? We're just not used to seeing it. But again, you can have a base be anything you want. It doesn't have to be a whole number. It doesn't have to be a pretty fraction. It can be a whacked out crazy thing. So on the left side, the right side, those two things cancel. And I'm left with 4-letter t. On the left side, I'm left with my crazy log thing. So then I would just divide by 4. So log base 1.0125 of 4 divided by 4. Now nothing cancels. I have to go straight to the calculator here. Just because you see 4s in both places doesn't mean you get the cross out stuff, so don't. The log base 1.0125 trumps that. All right, so don't cancel the 4s. So now we're ready to go to our calculator. Give me a fraction. Alpha window, give me option 5, log base. 1.0125. Inside the parentheses, I put a 4. On the bottom of the fraction, I put a 4. So that tells me it's going to take 27.8988 years. So if, let's say, for example, I had an extra $5,000 and I wanted to put it away for my granddaughter, and I was able to get it to where it was compounding at 5% interest and doing it for, quarterly and I was trying to figure out, well, when is it going to be worth $20,000? That way she's got maybe her wedding paid for, maybe she has a car paid for in the future. Well, it's going to take 27, almost 28 years. 0.8 of it, what's 0.89 times 12? Isn't it like 9 something? 10, so 10 months. So you're looking at 27 years, 10 months, and I keep going how many days if I want to keep going with decimal points. But it would take me 27 years, 10 months approximately for it to reach that 20,000. Okay? So it'd be something, if it was like my oldest daughter got married at, I guess, 27. She waited to get done after pharmacy school till she got married. So she wanted to have that settled before getting married. So, but